Hi everyone, in this video we are going to start talking about finite automata, finite automata and an automaton is basically just a machine. In our case it will be a model. More precisely what we'll be looking at are state machines. So there will be something like a state S1, then something happens, the machine goes to a state S2, then something happens, say I give an input and the machine goes to a state S3 and so on. So that's what a state machine is going to do. And what these finite automata are really useful for is to determine whether a string is acceptable in a language or not. For example, we looked at all strings ending with a 0. Now, given a string, let's say 110101, we need a computational model to determine whether this string is acceptable in the language that we defined. Of course, this is intuitively a trivial task, but to give a mathematical model for this is rather complex. So let's first go ahead and look at what an automaton looks like, and we shall get into the mathematical definition later. An automaton has a start state, so let's call this the start state as 0, and then based on any input it could go to a different state, so this will be the input, and then it can go to a state S1, and then it might so happen that based on some input this goes to itself, so the state S1 is retained based on some input IN2, let's say. So that's what a general automaton would look like, and it would also have a final state, or rather a set of final states. So let's say S2 is my final state, and that's represented by two circles. So based on some input IN3, S1 goes to S2, which is my final state. And there could also be a set of final state instead of just one. So what we do when working with these automata is we take a language or a regular expression which is given to us, then we make an automaton based on that regular expression or language. After we have done that, given a string, if we take each symbol of that string and pass the string through this automaton, it's going to give me if the string is acceptable in a language or not. So let's take the example of strings ending with 0 itself, and we're going to be creating an automaton for that. So let's just say that S0 is our initial state, so this is our start state, and then let's say I have another state which is my final state S1, and then what I'll say at this point is from S0, if I get an input 1, I need to retain the state S0, so this is my input 1, and if I get a 0, I need to go to my state S1, which is my final state, so this is on input 0, which means that if I just get from my start state an input of just 0, then I go to S1, which is a final state, so just the string 0 will be acceptable, so this is acceptable now. But what we need to do additionally is we need to say that from S1, if we get a 1 as our input, we go back to S0. So we are back to S0, and then whatever string I have is not acceptable. Whereas if at state 1 I get 0 again, then I retain my state S1. So here it is. This is the automaton that we've made based on the regular expression or the language given to us. And Let's actually try this out on a bunch of strings. So let's say I have the string 110101, which is what we saw on the previous page. And what we are going to do at this point is we are going to say I have a cursor or a pointer which is, let's say, here. So this right now I'm in my initial state, and then what I do is I say okay, so my next input is 1, and I was in state S0, so S0 was here my initial state. From there I got an input 1, so my next state is again S0, and my next input is again a 1, so I stay in S0. Now I have a 0 right here, so I go to S1, and I have a 1 now, so I go back to S0. um, I have a 0 now, so I go to S1, and then I have a 1 at the end, which takes me to S0. So if we look at this sequence, and I realize that I'm ending with an S0 here, that means that since S0 is not a final state, this string is not acceptable. And intuitively this makes sense because we said we are making an automaton for all strings that end with a 0. And let's look at another example at this point. So let's look at another example here. So the example I'm going to take is, let's say, 10100, and intuitively we know that this is an acceptable string in our language, but let's see whether our automaton gives us that. So I am here right now, and my current state is S0. Next, what I do is I say I've got a 1 here, so I go to state S0, so I retain state S0. Next, I have a 0, meaning I go to state S1. Then I have a 1 right here, taking me back to S0. And I have a 0 right here, which takes me to S1. I have a 0 again, which means I retain my state S1. And this is the sequence that I followed. And here we realize that we've ended with S1, which is a final state, so this string is acceptable in our language. So this is intuitively how automata are going to work, and in the next video what we are going to do is we are going to give a more mathematical definition for these automata. So stay tuned for it. I'll see you there.